The refrigerator, a household appliance that maintains a cool internal temperature to preserve food and beverages. By slowing down bacterial growth, it keeps food fresh for longer. But how does it achieve this feat? The fundamental principle behind refrigeration is the removal of heat from an enclosed space and expelling it to the external environment. This process is achieved through a cycle of evaporation and condensation using a refrigerant, a special fluid that can easily change from liquid to gas and back again. The refrigeration cycle consists of four main stages: evaporation, compression, condensation, and expansion. Let's take a closer look at the main components that make up a refrigerator. The refrigerant. This is the working fluid that absorbs and releases heat as it cycles through the system. This fluid is highly volatile, meaning it easily transitions between liquid and gas states. Evaporator coils. These are located inside the fridge. The refrigerant, in liquid state, circulates through these coils and evaporates inside them. The compressor. This is located at the back or bottom of the refrigerator. It compresses the refrigerant, raising its temperature and pressure. Condenser coils. These are also at the back or bottom of the fridge. The hot pressurized refrigerant releases its heat to the outside air and condenses back into a liquid. Expansion valve. This component reduces the pressure of the refrigerant, allowing it to evaporate again in the evaporator coils. Now, let's walk through the refrigeration cycle step by step. The cycle starts in the evaporator coils inside the fridge. Here, the liquid refrigerant absorbs heat from the fridge's interior and evaporates, turning into a low-pressure gas. This process cools the air inside the refrigerator since its thermal energy is being absorbed by the refrigerant. The low-pressure gas refrigerant then flows to the compressor. The compressor squeezes the gas, increasing its pressure and temperature. This is done to raise the temperature of the gas to a value above that of the outside air. The now hot, high-pressure gas is then pushed into the condenser coils. In the condenser coils, the hot gas releases its heat to the surrounding air and condenses back into a high-pressure liquid. The heat transfer is possible because the refrigerant is at a higher temperature than the surrounding air, and heat flows from high temperature to low temperature. This heat is expelled to the outside, which is why the back of the refrigerator often feels warm. The high-pressure liquid refrigerant then passes through the expansion valve, which reduces its pressure, causing it to cool rapidly. The cold, low-pressure liquid then returns to the evaporator coils, and the cycle repeats. A thermostat controls the temperature inside the refrigerator. When the internal temperature rises above a set point, the thermostat activates the compressor to start the refrigeration cycle. Once the desired temperature is reached, the thermostat stops the compressor, maintaining a stable internal environment. Lastly, have you ever wondered how your fridge's light bulb automatically switches on and off as you open and close the fridge door? Well, the key lies in the door itself. A switch is strategically placed at the hinged edge of the door so that when you open the door, the switch is released and the light goes on. Then once you close the door, the switch is pushed in and the light goes off. That's it for how refrigerators work. Thank you for watching.